In exercise 10-5, we have an object here, and it tells us to draw the front and right side view of the object and add the appropriate dimensions and tolerances based on the information that's given below. So what I have here is I have my front and my right side views already created. I'm going to switch over to my layout tab, go to my viewports layer, and create my viewport to start. So I'm just going to draw the viewport in here, click on the viewport and change the scale to 1:1. And then I'm going to hit escape to clear the selection, and then go ahead and go to my dimension layer to put everything in. Now, I'm going to go through and put in the dimensions, but there is one mistake in the book where it's on item C for exercise 10-5. It says assign the feature tolerance of 12.072 over 12 to the protruding shaft. That's actually supposed to be the dimension for this height right here. And it is not a feature tolerance, it's a dimensional tolerance using the limits option. So we'll get to that when I go to place my tolerances. The first thing I'm going to do is I'm just going to place all of the dimensions on here that are required to create the part. So we're just going to go to linear dimension, and we've got our overall dimension over here of 90. We've got our dimension to the center of that protruding shaft at 30. The height of this piece right here we've established as the 12. And I can either do the height of this, which is given in the book, or I can do the overall height. I'm going to do the overall height for this particular example. So once I have these dimensions in, this is pretty much all the dimensions I need on this view. So we'll come over here and we will place the dimensions that are necessary for the right side view. And I'm just using the dimensions from the other view to kind of line this up to make it look a little bit more consistent. So once I've got in my 30 and my 60 over here, I've got in my 30 and my 90 over here, I've got the height on this being at 40. So now I need to put in the diametric dimension, which is going to be a diameter of 40, and I'm going to do that over here. So the way I'm going to do that is a regular linear dimension, and then I'm just going to click and locate that. Now I have my properties window up because I know that I'm going to be using it for a lot of different things when it comes to the tolerances. So for this 40, the first thing I want to do is click on this, and then over here under primary units, my dimension prefix, I want to use the %% to get my diameter symbol in. So now that I've got that in, it's telling me for step A to define surfaces A, B, and C as primary, secondary, and tertiary datums respectively. So this surface right here is going to be my surface A. This surface right here, and we're looking at the edges of the surfaces, this surface here is going to be B, which is this actual surface. And then my tertiary datum, or datum C, is going to be this surface right here, which is actually this surface. So by calling these out on the edges, I can simplify my processes a little bit. So what I'm going to do in this particular instance, since I already have extension lines coming off of here, I know that this extension line right here I can use to mark surface B. This extension line right here I can use to mark surface C, and then I'll have surface A. Now, again, I'm going to be using the leader command, the quick leader command, which is LE enter, because it gives me options to create everything that I need to create within the leader command. So rather than picking my first point, I'm just going to hit the drop down and go to settings. So for this one, I just have regular M text. For my leader line and arrow, I want to use the datum triangle filled, and I can go ahead and say OK. Now I'm just going to pick a point and come straight up, and I'm going to label this as A. Now you'll notice that if you just go straight up and you only use one single point, it kind of kicks it off to the side a little bit. I would prefer that to be completely straight up, so I'm going to go back to the leader command, and this time I'm actually going to draw a little tag to the right. That way I know that it's going to come in correctly. So here we've got A. We can come off of here. This is going to be C. And then my last one for this particular instance, I'm going to come off of here straight to the left, and we're going to call this datum B. So I've got my A, my B, and my C all called out as my primary, secondary, and tertiary datums. Now, one of the rules about using datums is that you don't actually call out a surface you don't call out a surface as a datum if it's not being referenced anywhere. And what we're going to see as we go through the rest of this exercise, that surfaces B and C are never actually referenced by any other type of tolerance. Now, if you completely finish a drawing and you notice that you're not using those datum references anywhere, then they don't necessarily have to be called out on the drawing because they're not used. The ones that we want to make sure are always called out are the ones that we're using. So the next thing this tells me is to assign a tolerance of plus or minus 0.5 to all linear dimensions. So to do this, I'm going to click on one of my linear dimensions, and my tolerance display is going to be symmetrical, and my tolerance value is going to be 0.5. So this is going to give me that plus or minus 0.5. So now I can use my match properties, select on this one, and pick all the rest of the linear dimensions. So there we have all of our linear dimensions called out. Now, this 12 is the one that has the limits dimension applied to it. So I'm not going to do the match properties on this one because there's another operation that I need to do for that. So we're going to click here on the 12. And in this case for my tolerances, my tolerance display is going to be limits. My lower limit in this case is 0, but my upper limit is 0.072, which is the difference between the 12 and the 12.072 that the book is identifying that I need to use. So in this case, I am going to need to change my precision for that tolerance to 3 decimal places, and I do not want to suppress the trailing zeros because I want both values in this limit tolerance to have the same number of decimal places, regardless if they're used or not. So this is everything that's necessary for step B. I've got all of my symmetrical tolerances and I've got my limit tolerance in. So that's B and C. So now for D, I need to assign a flatness tolerance of 0.01 to surface A. So in order to do this, what I need to do is I'm going to use my leader command. And I'm just going to select right here, and before I do that I need to go back into the options because I'm set up right now for the triangle filled datum. So I want to go back to a closed filled arrow, go over to my annotation, select tolerance, and OK. Now I can pick my start point for my leader and put in my tolerance. Now this says to do a flatness tolerance, so we'll go to the symbol for flatness, and that tolerance is going to be 0.01. So we've got that in now, so there's our tolerance for this. Item E says to assign a straightness tolerance of 0.03 to the protruding shaft. Now, since it doesn't say to the center line, that means we don't need the diameter symbol in the actual feature control frame. But if we take a look at this a little bit further, item F says assign a perpendicularity tolerance to the center line of the protruding shaft of 0.02 at maximum material condition relative to datum A. So what we have on this particular shaft right here is we have a little bit of a compound datum that we need to use. So to do this, I'm just going to use the leader command, and I'm going to select right here and put in my tolerance. So we'll take this one at a time. So we have straightness of 0.03. So we'll select straightness 0.03. And we have another tolerance that's going to be right here. And in this case, we're going to have perpendicularity tolerance. So we'll click on perpendicularity. And this says to the center line of the protruding shaft. So that means I need my diameter symbol. And it's going to be 0.02 at maximum material condition to datum A. Once I have all of that information filled out, I can select OK, and it will put both of those tolerances in for this particular edge. And again, the center line here just alerts me that this is going to be using the virtual condition for the center line. But this is exercise 3 with all of the datums called out, all of the dimensional tolerances in, and all of the geometric tolerances in place.